Good morning. Let's finish up chapter 24 about lymphatic system. So the second part of this lecture is more about what you're going to hear in lab. Your lab instructor is going to show you a bunch of slides, and hopefully by learning about the theory behind it, your lab would be also easier. So let's start with this slide. It's called lymphopoiesis. Lymphopoiesis simply means making lymphocyte. Poiesis means formation of lymphocyte. After lymphopoiesis is done, after you make lymphocyte, the final result should be creating a lymphocyte that can fight against germ. When the lymphocyte can fight against germ, we call those cells immunocompetent. The lymphocyte must have competency to fight against germ. Those lymphocytes that they are not competent and they cannot fight properly will be removed from your pool of lymphocytes. Now, where this lymphopoiesis happens? Well, lymphocytes are made inside the red bone marrow, but the training part to become immunocompetent happens in two different places. So, production of lymphocyte happens in bone marrow, but after that, this lymphocyte can stay in the bone marrow to become competent. Those type of lymphocytes that stay inside the bone marrow to become competent are called B cells, and the ones that leave bone marrow and they go to thymus to become competent are called T cells. I hope you remember we have B cells and T cells. So why do we call it B or T cells? Because B cells stays in the bone marrow to become competent, but T cells are those lymphocytes that left bone marrow and their training happened inside the thymus. This picture shows that when the stem cell, hematopoietic stem cell, create lymphoid stem cell, some they're gonna migrate to the thymus, and those are the ones that create T lymphocyte. That some is gonna stay in the bone marrow, and those are the ones that create B lymphocyte and also natural killer cell. Some of these lymphocyte and macrophages, they cluster and stay together. If these cells stay together without capsule, without being surrounded by connective tissue, we call it nodule. If these cells they are together and they're surrounded by a capsule, then it's called lymphatic organs. So I want to separate lymphatic nodules from lymphatic organs. If cells are accumulated in one area without capsule, we call it nodule. If they are surrounded by a capsule, we call it organ. This is important for you to understand. So let's start with lymphatic nodules. Lymphatic nodules, as we said, is a collection of lymphocytes plus macrophages. These cells are next to each other, but they have some extracellular matrix surrounding the cells. Here's an example of a nodule. As you can see, it's a collection of the cells, but there is no capsule. If you look at this nodule, you can see the central part is lighter and surrounding part is darker. The center part is called germinal center and surrounding part is called cortex. So each nodule contains a germinal center and a cortex. The germinal center is composed of B cells that are proliferating and macrophages. Outside cortex is composed of T lymphocyte. So inside we have B cells and outside we have T cells. Inside also we have macrophages. An example of a lymph nodule is MALT. Remember we talked about MALT? MALT stands for mucosa associated lymphatic tissue. It's a lymphatic tissue or nodule that is found inside the mucosa. Mucosa of what? You can find in the mucosa of GI tract, respiratory tract, genitalia, or urinary tract. Let me explore this one with you. Remember we said mucosa is different than mucus. Mucus is a secretion, but mucosa is a layer. If you remember, in the very first week of this course, we said mucosa is a layer, is a membrane that lines all the cavity that opens to the outside. What does that mean? Let's say this is your GI system, your gastrointestinal system. Your esophagus, don't you think it's going to open to the outside? Of course it does. Your, let's say, small intestine has a lumen that food is going to go through, and then at one end is going to open to your mouth, at another end is going to open to your anus. Or respiratory tract, let's say this is your trachea. At one end is going to open to your nose, and on the other end is going to go to your lung. So it's going to open to the outside. Anything that has a lumen and opens to the outside is being lined by a membrane. It's called mucosa. So okay, let's say for the sake of this argument, this is your small intestine. When the food comes inside the small intestine, we want to make sure this food is clean before it's going to get to your blood circulation. So before this food is going to get to your blood circulation, we have to make sure it is clean. So therefore, in the mucosa, which is this layer, we have some lymph nodule. This is incorrect, not lymph node, but lymph nodule. It's supposed to be some lymph nodule to make sure when this food is passing through this wall and get to your blood vessels is clean. The same is true in the wall of your respiratory tract. The same is true in the wall of your vagina or reproductive system or urinary system. So therefore, we say collection of the lymphatic tissue in the mucosa is called MALT, mucosa associated lymphatic tissue. Where do you find MALT? Wherever you have mucosa. Where do you have mucosa? Anywhere that you have a tube that opens to the outside. Gastrointestinal, respiratory, genitalia, urinary tract. So in the wall of these organs, we have MALT. We have lymphatic tissue is located in the mucosa. The one that you have in the ileum, part of the small intestine, the MALT that you have in the ileum has a specific name. It's called Peyer's patch. This picture shows Peyer's patch. This is the lumen of your ileum. Food is going to be in this area. And here is your MALT. It's a lymph nodule, but because it's located inside the mucosa, we call it MALT. And since it's in the ileum, has a specific name. It's called Peyer's patch. So what's the function of lymph nodule? I already explained it to you. I said lymph nodule is going to fight with germs before they get inside your blood circulation. A tonsil is an example of lymph nodule, just like MALT is an example of lymph nodule. Tonsil has some capsule, but is not a complete capsule. So it's somewhere between an organ and nodule. Because remember, nodule doesn't have a capsule, an organ has a capsule. Tonsil has incomplete capsule. Where do you find tonsil? We find tonsil in the pharynx. Remember, we have three different types of tonsils. We have pharyngeal tonsil, we have palatine tonsil, and we have lingual tonsil. Let's take a look. Here's your pharyngeal tonsil that opens to the nose. Here's your palatine tonsil that opens to the mouth. And this is your lingual tonsil by the base of your tongue. We have three sets of tonsils. Tonsils are lymph nodules, although they have incomplete capsule. So what's the function of tonsils? The same thing we said about nodules. They trap antigen and provoke your immune response. I'm not going to go through the slide here, but very briefly, as you can see in this picture, this is a partial capsule, but then you don't see it here. When you look at the tonsil, you can see some gaps in the wall of the tonsil. These gaps is called crypt, and when you breathe, when you eat, the antigen is going to get trapped inside this crypt, and antigen can be exposed to all the lymphatic cells that we have inside the tonsil. So let's wrap it up very quickly. We said we have lymph nodules, which they don't have capsules, and two examples I gave you was MALT and tonsils. Now let's go to lymphatic organs. We have three lymphatic organs: thymus, lymph nodes, spleen. Make sure you understand, lymph node is different lymph nodule. Lymph nodule doesn't have capsule. Lymph node has a capsule. Therefore, lymph node is an organ. All lymphatic organs, just like lymph nodules, they are accumulation of a bunch of cells: lymphatic cells, lymphocytes, and macrophages, dendritic cells. They're all collected together, but then they are being surrounded by a capsule. Let's start with thymus. Where is thymus? Thymus is sitting right in front of your heart. Let's take a look. This is the heart, and this is thymus. When you look at the thymus, you can see it's composed of two lobes. When you look at inside the thymus, we notice that the capsule is going to penetrate inside the thymus and create something that's called trabeculae. So this is called trabeculae. We divide each lobe in a bunch of lobule. Each lobule is composed of a cortex, which is darker, and medulla, which is lighter. Cortex is composed of immature T cells, and medulla is composed of mature cell. What does that mean? Do you remember a few minutes ago I told you that bone marrow creates lymphocytes, and some of this lymphocyte travels into thymus to become immunocompetent, become a soldier that can fight? So the thymus is going to host this lymphocyte. The lymphocyte is going to stay in the cortex, and as they train, they're going to enter to the medulla. So medulla contains trained T cells, or it's called mature T cells. Cortex contains immature T cells that they are there to become trained. Now, why is that after puberty the size of thymus is going to decrease? Why is that thymus becomes less functional as you grow up? Well, because those cells that leaves your bone marrow and come to the thymus, they come at the early age. All the training happens when you're young. After training is over, we don't need thymus to train anything. You cannot train any new cells. As a result, the function of thymus is going to decrease, and therefore the size of thymus is going to decrease. Now let's talk about lymph node. Lymph node, as we discussed before, is a small node that they are sitting along the pathway of lymph vessels. When the lymph is moving up toward your blood circulation, before it's going to reach to your blood, we have to make sure this lymph is clean, and therefore the lymph is going to pass through a bunch of nodes are called lymph node. The size of lymph node can be as small as 1 to 25 millimeter in diameter. So what's the function of lymph node? Fighting against germ inside the lymph. Your lymph node should not be palpable, but if it becomes palpable, that means your lymph node is too big, and as a result, you're concerned that probably there's something is happening in your body. Lymph nodes have tendency to get together. You have a bunch of cluster of lymph nodes in your body, but there are only 3 areas that you can touch them and you can feel them. We have other clusters, but you cannot feel those. The one that you can feel is in the axilla, by the inguinal, and by your neck, cervical. This picture shows the location of lymph nodes all over your body. But the one that's palpable, the one that you can feel, is the one that's more superficial by the inguinal, by the axilla, and by your neck. That's why when you go for a doctor visit, doctor is going to check those areas to feel if your lymph node is enlarged. Lymph node, like any lymphatic organ, has a capsule. When the capsule penetrates inside the lymph node, we call it trabeculae, as you saw it before. Let's take a look at this picture. Here's a lymph node. It's a bean shape. It's a capsule. And when it's going to penetrate inside, it's called trabeculae. Your lymph node is composed of central part is called medulla, and the outside part is called cortex. Inside the cortex, we have a bunch of lymphatic nodule. Each lymphatic nodule, as you remember, has germinal center and has its own cortex. Let's make this nodule bigger. Remember, like any other nodule that we talked about, in the germinal center, you have your B cells, you have macrophages, and it shows here dendritic cells. I hope you remember dendritic cells. In the cortex, we have T cells. Now, as you can see, surrounding this lymph nodule, we have some lighter area. This lighter area is where the lymph is going to flow. So lymph is going to come inside this lighter area. This lighter area is next to trabeculae, and that is called sinus. A sinus is where lymph can flow. The sinus in the cortex is called cortical sinus. The sinus in the medulla is called medullary sinus. So this white area you see here is a medullary sinus. And this white area here is a sinus, but it's called cortical sinus because we are in the cortex. Now in the medulla, you have collection of the lymphatic tissue. This collection of lymphatic tissue is called medullary cord. So what really happens is lymph is going to come inside the lymph node and it's going to pass through this cortical sinus and it's going to get close to these lymphatic cells, B cells, T cells, macrophages, and they're going to start working on the lymph to make sure it's clean. This lymph is going to pass through the cortical sinus and it's going to come to the medullary sinus, and again it's going to be next to other cells in the medulla, and those other cells are B cells and plasma cells. So this medullary cord contains B cells and plasma cells. And finally, when the lymph is clean, lymph can leave the lymph node through this vessel. It's called efferent vessel and continue the journey toward blood circulation. The next and last organ is the spleen. The spleen, in a sense, is different than other lymphatic organs. Why? Because other lymphatic organs, they're going to clean lymph or fight with the germs that enters your body, but the spleen cleans your blood. The spleen is going to filter blood. The spleen also is a reservoir for your erythrocytes and platelets. If you squeeze your spleen, you're going to push all these erythrocytes and platelets inside the blood circulation. So many platelets and red blood cells are inside the spleen and they are not part of your blood circulation. The spleen, as we said before, is a graveyard for red blood cells. Red blood cells, when they get to the spleen and they're old, the macrophages inside the spleen is going to take them and remove them. And finally, if your blood is not clean, if your blood contains bacteria or other foreign material, the spleen is going to take them and destroy them. So therefore, remember, spleen cleans your blood but not lymph. A spleen, like any other lymphatic organ, also has capsule. The extension of capsule inside the spleen is called trabeculae. This is spleen. Where it's located at is in the left side of the body, under the diaphragm, next to your stomach. The spleen is the largest lymphatic organ that we have in our body. This is your spleen. This is the diaphragm, pancreas. The stomach is being removed here. If a stomach was here, you could see fills this space. So this is your spleen. On the right side you have liver, in the left side you have spleen. This is your kidney, as you can see, this one. We said the capsule of the spleen is going to penetrate and is going to create trabecula. Inside the trabecula we have a vessel we call trabecular vessels. This vessel contains artery and veins. We call splenic artery and splenic vein. I hope you remember that spleen, liver, and bone marrow have large capillaries, and those are called sinusoid. So the capillary inside the spleen is called sinusoid because they are very large. When you look inside the spleen, this is trabeculae, and inside the trabeculae you have blood vessels. Surrounding trabeculae, you have two different distinct structure. One is called white pulp, like this, and this, or this. And between the white pulp, we have red pulp. So this is a red pulp, this is a white pulp. White pulp, and here's red pulp. So anything is left is called red pulp. In the center of the white pulp, you have an artery. It's called central artery. Therefore, we say white pulp deals with artery or is associated with artery. Red pulp associated with the vein. Let's take a look at this drawing picture. If this is your white pulp, this is the artery. So white pulp associates with artery. Outside the white pulp, what is left is called red pulp. And as you can see, red pulp associates with vein. White pulp contains a bunch of cells, T cells, B cells, and macrophages. Red pulp, on the other hand, mainly has macrophages. Now, let's explore this red pulp. red pulp is the one that has sinusoid, those large capillaries. And also red pulp contains something that's called splenic cord. What is splenic cord? Do you remember at the beginning of this course when we talked about different type of connective tissue, we said we have one form of loose connective tissue, and that is called reticular connective tissue. I hope you remember that. If you don't, please go back and take a look. One form of connective tissue that we talked about was loose connective tissue. And an example for loose connective tissue was reticular connective tissue. And I said that time, reticular connective tissue create stroma or scaffold of lymphatic organs. I said, if you look at the spleen, you can see reticular connective tissue. The ground area of the spleen is composed of reticular connective tissue. Reticular connective tissue is found in the red pulp. And this reticular connective tissue is called splenic cord. So splenic cord is a reticular connective tissue of the spleen, and it contains lots of macrophages. And that is going to bring us to the end of this chapter. I hope you enjoyed it, and I will see you with the next recording with a new chapter. Have a good day.